everyone, my name is Xun Cherng. We are the group 1 under the third grade.
I am Chang Xin Jie. I am Veronica. I am Stalorna. I am Suzette, and we are currently at Kuching and Sibu.
Our visit focused on the Pembinaan Baharu Sekolah Menengah Pendidikan Khas Vocational SMPKV Padawan Sarawak, Rekan dan Bina, a design and build DNB project for the Ministry of Education. This contract is valued at 78,999,000 ringgit. We also observed a 3-story supermarket complex on lot 3070, Block 3, Sibuton District with inclusivity units valued at approximately 40 million, excluding professional fee.
I want to ask you a question. What are the common challenges faced by QS on site?
Like you need to confirm the drawing must be latest first kit of the drawing kit updating like version B
and because the drawing is often
changing.
Okay, thank you.
Part 3. Self-observation showing element related to SSM2, reinforcement and one-step control. We are observing the foundation work where the QS applied SSM2 principle to control material. Reinforcement steel bar are measured by mass in tons. The QS used rigorous stop and control to fight wastage. We learned that steel come in 12-meter lengths. Any leftover portions such as a 2.2-meter piece must be used elsewhere to minimize unnecessary material expenditure. Next, observe the temporary formwork used for beams and columns. Although measured by area square meter, implied formwork economy efficiency is tied to its lifespan. The size M from maximum reuse it try with oil, it can be recycled 10 or 20 times, far extending the 3 to 5 times if uncared for. This is a core pillar for economical design. Foundation elements are measured by their requirement. Piles are measured by drive depth such as 30 meters. Furthermore, structural components using the industrial building system IBS such as precast columns and bunds are counted and measured in piece. This system requires accurate piece-by-piece measurement, ensure compliance with standards for work below ground floor, finish level, and upper structure.
So for this demonstration, I'm going to show how to measure a foundation element using the usual breakdown, such as excavation, concrete, formwork, and reinforcement. First, excavation. When we look at any footing, the main thing that we look is measure the length, width, and depth of the pit. From there, we calculate the volume in cubic meters. It's important because even small changes on site can affect the total cost. Next is concrete. After the hole is prepared, the concrete quantity is based by the final size of the footing. This is also measured in cubic meters, and we check it against the drawings to make sure the amount poured matches what was planned. For the formwork, we measure the surface area of the footing in square meters. This is because formwork payment depends on how much area is covered by the boards or panels. And lastly, reinforcement. Here's the rebar cage. Reinforcement is measured by weight in tons. The QS will refer to the bar schedule to confirm the bar sizes, spacing, and total weight, and then compare to the actual steel on the site with the calculated quantity. So overall, this measurement breakdown helps us to accurately determine the cost and materials required of each foundation element on site.
To conclude our comparison, we learned that quantity surveying practice can vary depending on project requirements, but the core QS role of cost and quantity control remains the same. We also discovered that different standards are used for different project types, such as SMM2 for building works and MyCESMM2 for civil works like the SMPKV project. Site conditions, especially issues like the pit soil in Matang, require costly ground treatments to prevent future structural problems. Lastly, we understood how contract methods differ. with design and build placing greater responsibility on the contractor and requiring systems like IBS to ensure quality and faster progress. That is all from us. Thank you.